Hey guys, Joe Pye here at Advanced Innovations. Welcome back to the shop. One thing I have to say about this kit, it is like having a $5 bill in your hand when you're 5 years old, standing in a candy store. You just don't know what to grab first because, it all looks so good. So my heart is pulling me right here. This particular cross slide assembly, got a couple pieces of it. We've already done the tool post, tool wedge, lantern style, T-nuts and such. And I've already done the handle for it. So this is just calling my name. There's a couple of good technical features here. We have some dovetails. We have an extremely long left hand 540 thread. So this is going to be single pointed. I'm not going to run a die on that. And we're going to need to modify the machine a little bit, make a little follow rest for that. Can't have a stationary because I do want to run a gauge on it. I will make the compound first so I can use the compound as the gauge for here. I'm going to show you the method for measuring that with pins and blocks and micrometers. And one thing I got to point out, if you look this model over real good versus the picture, what's different? Well, it looks like a real machine, doesn't it? This guy right here, there's a dial on this one, and there's no dial on this one. So I did call the manufacturer and he said, well, that's a display piece and that's our museum quality build. And I said, well, I got to have me one of those. So we're going to figure out exactly what they did, and we're going to put graduated dials on this cross slide because it's just how it has to be, right? If you're going to do it right. I believe the first thing I'm going to do after I modify the machine, put my follow rest on there, I will do component number 27. I will do this. This is 1 1/8 or 1 1/4 long, 1/8 diameter, 540 left hand. And I will single point that. We're going to make that first just because that's what the universe tells me to do. All right, let's get over there and do it. The production of this particular component right here, the cross slide screw, has given me an opportunity to demonstrate something that I think is really important to show. And I do apologize for not getting to the cool stuff on this model just yet, but the weather and recent workload has preempted the effort there. I'm going to take a piece of brass, this piece of brass right here, it's about 5 inches long, I guess, 1/8 inch in diameter, 125, and I am going to single point a 540 left-hand thread on there without putting a center in. Now, I'm going to first attempt to do it unsupported, and I'm going to show you what's going to happen. It should be an absolute, almost instant, catastrophic failure, and then I'm going to show you an attachment that's in the thumbnail, and we're going to see if that works. Good, bad, or indifferent, I will record that. And just for sake of continuity here, when I do these, I'm going to do the tailstock spindle screw and the cross slide screw at the same time. Well, not at the same time, but basically on the same day, same kind of setup. Now, the reason this is a left-hand thread on these guys, because when you turn the crank clockwise, you want to reject the control surface that you have, whether it's a mill table or a cross slide or whatever. When you turn it clockwise, it has to push away, and the only way for that to happen is for it to be a left-hand screw. All right, so let's put this in a 1/8 collet, already set up. And just try to run 1 1/4 inch long 540 thread. Now, it's not going to be pretty. I can pretty much promise you that. I am going to thread away from the collet, so I'm going to be threading left to right. The tool is going to be up, and that should give me the left-hand thread. If the machine was running in reverse and the tool was down, threading out, that would give you a right-hand thread. So tool up, spindle running forward, threading out, left-hand thread. Let's do it. For sake of anybody that's going to say, hey, what was that tool holder you're using? It is a Kennametal top-notch threading grooving tool holder. NSR 123B. I don't know if this is discontinued or not. I've had it since I was about 2 years old, and I love it. And you can see how versatile it is. These inserts actually come in a left profile, like shown here, a center profile, or a right profile. And the center profile is a full bite, and the left and right profiles are partial bites like this one here. And you can also control the nose radius when you order. So if you're doing a real fine thread, you want a real pointy tool like that. All right, NSR 123B. Tool up, feeding out. Part is extended about 1 300, a little bit over 1 1/4 inches as far as the print is concerned. We can expect this material, I'm going to run it real slow because it is flimsy and it can whip. So I'm not going to run it at a really high RPM. I can expect this tool to get somewhat into this cut. Then if it makes it to the end while this material stays on center, it's going to chatter like a big dog. And the expectation is for it to go up and over and walk onto the top of the insert. And that is what I would consider a catastrophic failure. So let's take a look and see if that happens. I wholeheartedly expect that to happen, 100%. Initial penetration here is going to be about 5 thousandths per side. That's not a whole lot. All right, 5 thousandths deep. Very pleased with the fact that it didn't climb up and over, but you can see the depth of the thread is extremely different from here to here. That would indicate that this is pushing away or lifting or whatever, but the depth is not the same and there is a taper going on. So let's take a little bit deeper cut and see if we can get this thing to blow. Another 10, that'll do it. If you were watching very closely, as the tool got to about the center point, the material did find a happy place riding above center. It did not come and jump over top, as it probably would if this was twice as long, but it did walk out and up. I will run that cut one more time. Watch the deflection. Watch the movement of the material when the tool clears off the end of the part. Watch what happens. Take a look. A little closer look at the thread. You can see the penetration starts off at a very specific depth at the nose of the collet, and as it walks out, it is almost invisible. So that is not the catastrophic failure that I thought, but as far as the features concerned, that is just a joke, and you're just going to be screaming all afternoon. This guy right here is the follow rest that was intended to be used on this machine. And if your machine is set up for a follow rest, I think I said follow rest, which it is, you're going to find tapped holes in the carriage. That is where it attaches. It's not like a steady rest. The steady rest bolts right to the machine and stays put. Follow rest moves with the tool. I grabbed some of the LE phenolic I have laying on the shelf, and this is what I put together this morning. Standoffs will keep the recess in the machine. Since that is a cast surface, I want to rest on those machine counter bores where the threads are. So the brass plugs will go in there. Here is my single finger that is going to point. It's going to point that way, in case you missed the moving arrow on your screen. It is going to move towards the operator, because everything here is behind me. This is the plate that will hold the screw threads, because I'm not a big fan of putting threads in linen phenolic, although it is pretty tough and it will hold up. I like to back it up with something more robust. Let's assemble this thing onto the machine and give it a go and see if the response is any different. First part of the assembly, flat washers on the outside, bevel washers on the inside. And since I only have two hands, I will set this up on a tripod and we can take a look at it in a second. There's the initial installation. Now when I laid out the center of this, I put a 1/2-inch rod in the machine. Move the riser into position, and I put a square on the back side, and I lowered the square, the combination square. Matter of fact, it's right here. Lowered the combination square down the back side of this until I hit the top of the material, scribed the line, and did the same thing from below. And working from the middle point of those two lines, came up with my center height. And once you see how I'm going to prep this, you'll know that the center height is not totally critical, but you're going to like what you see. Support finger is in the channel on the upright. And there is no specific geometry to this, but I do have it so that all aspects of this machine can swing and be adjustable and everything clears. Next phase is to prepare the tip. Like I said, good, bad, or indifferent, I'm going to show you how I'm doing this. This is a 1/8 end mill in the collet. I am going to traverse the entire carriage, and I'm going to put a footprint in the tip of this part right here. And it is currently stroked all the way back in the channel. So depending on how I like it, if I have to cut anything, I can advance that and renew the seat. So let's check it out. We now have a 125 diameter follower machined right on location with the collet. Now for everybody that's going to say, hey, that's not fair, what if you don't have a oddball size end mill or cutter? Well, just make this a right angle. The important surfaces are to the rear and to the top. So this could be a square notch right there, and it would probably work just fine, because those are the two directions of deflection on an extended material. Let's put the real material back in there, duplicate the cut we just took, and see whether or not my little gauge goes on. This is a 540 left-hand thread. All right, moment of truth. 770 RPM. Spindle's turning forward. Carriage is feeding left to right. And this camera is right where I should be standing, because you can't see it when I position it normally. Let's watch the depth of the thread. It's either going to burn up instantly or it's going to work like a charm. We're going to find out together. And that's pretty. All right, now everybody's going to beat on me for using a tapped piece to check apart, but I always say if you're going to control the assembly forever, have at it. If you're going to send it to the other side of the world or the other side of town, use gauges. Don't ever do this. I hate people that do this. I don't hate them. Just rather not do it. That is an incredibly consistent top on that thread. I am very pleased with that. I chose the linen phenolic because the linen phenolic will somewhat yield. I did not want to use a material that would stick, gall, transfer, cold fuse, whatever you want to call it. But I think the LE phenolic is going to be a win. And once you've got that seat in there, it doesn't matter what you do with your cross slide, this seat's not going anywhere. So you can come in and out with the tool all you want, and nothing's going to hurt. So let's see if we can run a couple more passes, get that barrel to go on there. That is right there. The real tell is how nice it fits all the way down. But I wish you could feel the tip of this material. It almost feels like you've run emery on it. I don't know if it's a byproduct of the phenolic, the abrasion characteristics of the phenolic, but it feels like it's taking the burrs off of this as I'm cutting it. I am very pleased. I'm going to take another 3 off. 2 more passes. First pass will be 3/1000ths. Second pass will be a dead pass at the 3 thou depth from the previous pass. I'm going to bet this is a win. Absolutely beautiful. Well, I wouldn't have bet that was going to be possible. Let's put that on the bench and get a closer look at it. I'll compare both ends. I think the time that you're going to spend making this little outrigger attachment is going to be time well spent. There you go. Profile of that thread is just absolutely beautiful. It's nice and clean too. There's no noise in there. And this end, that is without. So whether you're turning or threading or whatever you're doing, if you have a piece of material that's hanging extended far out of however you're holding it, make sure that you do support it. You will get a taper, you will get noise, you will get failure. So that's all I got for today, and stick with me, bear with me on this mini engine lathe. This is actually a setup that I will be using for those 2 components that I told you about, but I thought that it was just as interesting to show you the setup all by itself. Hang in there. Next week is going to be heavy on the lathe videos. Thank you very much for watching. Stay well. Joel Pyatt, Advanced Innovations in Austin, Texas. I'm out.